All right, welcome back. Today we will derive Fick's first law. Now, of course, you already understand the physical meaning of this this equation for steady state, but how did we get this equation? How? And what is this diffusivity? How did we get this constant? That is what we are going to do today. Okay? So imagine two walls. We call it, let's call it plate 1 and plate 2. And this plate will be full of atoms. Actually, let's draw it better. Like this. Oh wait, that's too big. It will be full of atoms here also. Now imagine this wall is very, very big and it has a lot more atoms than this. It's not 3 atoms, of course. So there are N1 atoms on plate 1 and N2 atoms on plate 2. And we call this alpha is interatomic distance. Now, when you think about the atoms here on the plate 1, then this atom will have a jumping frequency. We call it jumping frequency, gamma. Of course, it has a unit of per second because it's frequency. So basically it means how many times it will jump. Let me write it for you. So how many times the atom jump to unit diffusion length. You know what, let's just call it interatomic distance. Jump to a point that is interatomic distance far away. Distance, which is alpha, right? Far away per unit second, per unit time. This is what jumping frequency means. So when it jump once, it will only jump with a distance alpha. Every time it jumps with a distance alpha, right? That's what I mean. So, of course, then the physical meaning of flux should be, so basically you have 2 plates now, right? Like this, with interatomic distance. Like this. Then, physical meaning of flux should be Okay, so the physical meaning of flux should be number of atoms passing through a plate at given time, right? This is the physical meaning of flux. Then, so I forgot to mention that the areas of these 2 plates are unit area. So unit area plates. Therefore, N1 and N2 should have a unit of atom per unit area, right? Then, when you think about atoms here, it has two possibilities because this is a one-dimensional system. It only moves in this direction or this direction, one dimension. So it has two possibility. One is moving right, one is moving left, and it has equal possibility to do that, right? Equal probability, right? Therefore, in entire gamma, only half of it is responsible for moving right, and only half of that, the another half is responsible for moving left. Therefore, the flux that moves right for N1 atoms in plate 1 should be, flux that moves right should be half of N1 times gamma. Because now this has a unit of per second, this has a unit of atom, or you can say gram, per unit area, then of course you can easily get that it matches the unit of flux, right? And of course, when you look at this for plate 2, it's the same. So when we consider that moves left, then it is the same, N2 times gamma. Then the net flux that moves from plate 1 to plate 2 should be like this. Right? And I told you the distance between these two plates are interatomic distance, meaning the distance is kind of like lattice constant, or interatomic distance is this scale, this alpha. It's not like it's 1 meter or 2 millimeter or micrometer. Is very small. It's a nanometer scale, Armstrong scale, okay? It's a interatomic distance, meaning that this is also alpha, this is also alpha. It's just like in the crystal, you know that the close pack system, right? Something like this, and you can call this alpha, right? So this is alpha. Then you can see that the concentration on plate 1 should be equal to N1 divided by alpha. This has a unit of gram per unit area, because this, I already told you that this plate has a unit area, meaning area of this is 1 centimeter squared, and this is alpha, so this should have a unit of centimeter. Of course, it should be 10 to minus, I don't know, 7 or 8, but it is something like that. It has a unit of centimeter. Then this concentration should have a unit of gram per cubic centimeter. Now we can replace this, N1 equals to C1, so concentration on plate 1, and times alpha here. Same logic for N2 equals C2 times alpha. Then J net should equal to gamma, alpha, right? N1 minus N C1 minus C2. Okay, so then it should equal to this. Right? Then it equals to gamma alpha 2 delta C over delta X. Then we call this diffusivity. That is the physical meaning of diffusivity. This is jumping frequency. Okay? Then this will be equal to Fick's first law. For steady state diffusion in one dimension. All right. Now, of course, in 3D, you have 6, we call it degree of freedom. So the direction that you can move is 6 ways. So instead of 2, you should divide by 6. So D will equal to, so 6 gamma alpha squared. We can call it lambda squared. Then 6D equals to N over T lambda squared. Then 6dt equals to N lambda squared. Now this is the famous Einstein's formula, I think, for random walk. Now we will get into this in phase transition, okay? Now, so much for today's lecture. Thank you for watching.